Hello everyone, welcome to my channel Kit C Patel Metallurgy. Guys, today we'll see a concept that is Bragg's law. Okay, so we'll see this. So if you see the equation, then Bragg's law is something lambda is equal to 2d sine theta. Yeah, where lambda is what? Wavelength, d is interplanar distance, theta is angle of incidence. Okay, if you draw the schematic, then you can see here this is the plane, and this is the interplanar distance d, and this is your normal, and this is angle of incidence, and the wave of lambda wavelength, and lambda, and this is what? X-ray, and this is your reflected or diffracted beam. Okay, now we'll see that why this equation is valid, and what happens when this equation is used to show that some diffraction is taking place. So why this equation come? So now we'll see first. Let me delete this. Okay, now we'll have to understand something related to wave. Wave, and in the wave there is a constructive interference and destructive interference. Yes, now suppose there is one wave which is traveling like this, and there is another wave which is traveling like this. Yeah, and this is what? 0 pi by 2 pi, 0 pi by 2 pi, and so on. So if these two waves mix with each other, then what will be the result? There will be no amplitude, or there will be no wave. It will result in complete destructive interference, because here it is positive and here it is negative, so positive negative gets cancelled. Okay, this is for case 1. Suppose this is case 2, where a wave is like this. Okay, and your second wave, suppose it starts from here. Okay, and this is what? 0 pi by 2 pi pi, sorry, it is pi and 2 pi, sorry for that. Here also it is pi and 2 pi, so your pi by 2 will be here. Okay, now here there is this wave is generated from this position, so if these two are mixed, suppose, then what will happen? There will be intensity as such, or the wavelength, the some amplitude will be there up to this position, and at this position what happens? This plus and plus will be added, and there will be a rise in the amplitude, and here in the negative also there will be rise, positive there will be rise. So what is happening over there? This is nothing but a constructive interference. Yeah, okay, so you can see here, and this distance, if you see, this distance is lambda. Yes, you know about it. So whenever the two waves which are separated in multiple of lambda, suppose this will be 2 lambda, suppose this two wave generates from here also, then again there will be interference, constructive interference will be there. So if two waves are separated in integral multiple of lambda, then there will be constructive interference. So in the case of diffraction also, let me delete this. In the case of diffraction, this is the diffracted beam. So what happens, since there are atoms over here, assume there are atoms, whenever X-ray hit one atom, then it can be diffracted or it can be reflected in any direction, like this, but what happens whenever it gets a certain plane, then what happens, the another wave which hits the same plane, you know that gets diffracted or gets scattered in such a way that these two waves mix with each other and you know produce a single wave, and it produces a single wave, and which helps to detect that from this plane diffraction has taken place. Okay, so now we'll try to see here. Suppose this is the plane and this is what interplanar distance. This is the incident ray and the reflected ray, and here it is your normal. Similarly, there will be another wave. Okay, so we need to find the lag of this wave 1 with 2, that is the path difference. So basically we'll draw perpendicular from here to this. Let us assume at O, A, B and C. So what is the extra amount of distance which this wave number 2 has traveled? This is nothing but AB plus BC, right? Because if you see these two are equal, and then these two are also equal. So what is the extra path? That is AB plus BC. Now here it is theta, yes. So this will also be theta, this will be also theta, yes, and this is 90 degree. So here sine theta, we'll calculate sine theta. Sine theta is equal to AB by OB equal to AB by D. OB is nothing but interplanar distance. So AB is equal to D sine theta, right? So similarly, BC is equal to D sine theta. And what was our path difference? That is AB plus BC. That is equal to D sine theta plus D sine theta equal to 2D sine theta. Fine. And for diffraction to happen, this path difference should be in integral multiple of lambda. So this will be written as 2D sine theta equal to lambda. And this is what is Bragg's law. Okay guys, thank you. Hope this lecture will give you some idea